We are going to be learning to graph a sine and cosine graph and looking at horizontal and vertical shift. Now, we have covered this before. The hardest part will be the understanding the x-intercepts. So the first thing that we need to understand is cosine is starting at 1 and goes down into -1. Whereas if we are looking at our sine will start at the origin of 0. So straight away, if we've got a vertical shift, it means that we are pushing these values up by 2. So keep in mind, knowing these 4 points, 1, 2, 3, 4, and 5, sorry, 5 points, and knowing those that they are shifting up, and that will help us graph everything. So again, with sine, if I've got sine take away b, it's going to be pushing it down. So the first thing I want us to think about here is the amplitude of 4 sine 3x plus pi over 6 minus 1. So the amplitude will always be the number in front is 4. You might notice that I'm just ignoring the domain for now. I'm just wanting to get everything that I know out of this equation. The period is always going to be 2 pi, and then it's always going to be affected by this 3 in front of the x. So we will just go 2 pi divided by 3. Our horizontal shift, another way of thinking about horizontal is how do I make this bracket 0? I will take away pi over 6 and then I'll divide by 3. So that gives us negative pi over 6 divided by 3, which is negative pi over 18. So that is our shift, which means we are doing a shift to the left horizontally. Vertical shift is always what's on the outside, which is our -1. So we'll be going down by 1. So let's put these parts into order. First thing we need to understand is the basic sine graph, which is a period of 2 pi, starts at 0, goes up to 4 because it's amplitude of 4, down to pi, down -4, and then at 2 pi it goes to 0. So we know that part. The next thing when we have this 3 here, it's um, our period is going to be shifted. So now our period is going to be 2 pi over 3. So when we are labeling this, the major thing that we need to be thinking about is if this is 2 pi over 3, half of that is pi over 3, half of that is pi over 6, and then pi over 3 plus pi over 6 is pi over 2. That helps me label. These are the key points that I am going to use to be able to graph this effectively. The next part that we've got is that horizontal shift, and we know it's going to be pi over 18 to the left, which means my intercept will be shoved over here, so it won't be at 0. So we can see that just by me putting the graph up here. Each of these points that we have, we need to make sure that we are knowing that it's gone across by pi over 18. So if I'm calculating correctly, I'll just go pi over 6, take away pi over 18. Then this point here was pi over 3, take away pi over 18. This was 3 pi over 6, 3 pi over 6, take away pi over 18. And finally, 2 pi over 3, take away pi over 18. That's the first step that we are doing. I'll simplify that in a minute. The next part is we are going to put the vertical shift in. So it's shift down. So as I solve this, it'll be what's 4 take away 1, 3. So we can see here it's going to be 3. So 2 pi over 18, 3. The next one is it was originally here, has been pushed down. So again, that is going to be 5 pi over 18. So that's pi over 3, take away pi over 18. Likewise here, again, we are just taking one away, so we get to -5, so it's 8 pi over 18 minus 5, and finally, right here, will be 11 pi over 18, -1. So that's the first step. The second part is we need to find all of our intercepts. A lot easier if we can use the class pad, we can just type it in and graph it. But if we can't, we need to understand how. So the y-intercept is probably the easiest. We are doing exactly what we've always done to find the y-intercept. We are making x 0. We are solving it, so we get 4 sine pi over 6 minus 1. We know, if we know our exact values, sine pi over 6 is a half, which means we've got a half times 4 is 2. 2 take away 1 is 1. So when x is 0, we have a y of 4. Okay, again, just make sure you put the point and label it on your graph. The final part that we're going to look at is our x-intercept. Now, this is probably the hardest part to do if we're not using a class pad. So the first thing I'm going to do for an x-intercept is I'm going to make y equals 0, which is standard. I'm going to slowly move everything over to the other side. So I've got 1 goes over, and then I'll divide by 4. Now, first thing, we need to be thinking about our radius. So let's just break this down for a minute. We're going to get sine to the other side, and that normally gives us our theta. And our theta is going to be worth 3x plus pi over 6. So this is where we need to understand this part right here. Sine negative 1, 1 over 4. So 1 over 4 is positive in quadrant 1 and 2 because we've got SACT. So S is sine in quadrant 2, all is in quadrant 1. So that's what we are going to be using. So based on that, we know in quadrant 1 it will just give us theta will be the inverse of sine 1 over 4. And in quadrant 2, we always start off, and we always start off with our pi here to find this angle here. So we'll go pi, take away theta, and we know what theta is already. It's pi sine negative 1, 1 over 4. So that gives us two amounts. Okay. Now, we also know that sine repeats every 2 pi, so we're going to include that plus 2 pi. Now, what you notice that what I'll be doing is putting an n value next to this. So that means we can keep on repeating this throughout the whole circular function if we did not have a restriction. So what I could do, I could say we've got theta equals sine negative 1, 1 over 4 plus 2 pi, and I could also do um, it as pi take away the inverse of sine 1 over 4 plus 2 pi. Again, I could put an n here, which I will do the next step, just so you can see. Then we're just going to substitute our theta back in. So we know what our theta was. Our theta was 3x plus pi over 6. So this is where I substituted it in. Now on the calculator, I just solved this. So I'm not going to do all the calculations because it will take a lot of time, but I just used the class pad and solved for x. So the first thing I did here was for n on the first equation, I made us 1, and that was able to help me find this point right here. And then on the second one, I couldn't use 1. I had to use 0 to find this intercept here. So be mindful, you do need to think about what numbers you are putting in and thinking about what are the values of pi over 6 and pi over 3 to help you. So that gives me x equals 2.004 and x is equal to 0.788. And all you need to do is just label those 2 points and you've labeled everything. The only thing I haven't done, which I've left because I was showing all the steps, is we do have a domain with endpoints. So then I need to stop my graph here at 2 pi over 3 and I would have to label this point. So x is 2 pi over 3, y is 1. The other point that would need labeling is this intercept because it says the domain stopping at 0. I've already got it labeled, but I wouldn't have the graph going any further on to the left. I'll stop and start at this point.